So good morning, everybody. My name is Yusuf Khalidi. I'm here with our team here from Azure Networking to tell you about a number of things. This talk is both an overview of Azure Networking and for those of you who are using our system, an update over the whole networking space of all the new features we are announcing this week. Everything I'm describing today is available in the cloud at the moment in preview or GA mode, or will be very, very imminently so. So there's nothing about the future here. It's about the here and now and all the new features. So if you're very familiar with our system, bear with me. I'm going to give you a bit of background, motivate some features. And otherwise, if you're new, I hope to give you an idea of the breadth of features we have in the system. I want to note one more thing. We have 6 or 7 sessions at this event around Azure Networking. This is the overview session. If you're interested in any given subject, please look up the corresponding detailed session. Okay? So let me quickly tell you, if you have to leave the room right now, remember this one slide. This is everything we are announcing this week. A lot of stuff. The idea in the next hour or so is to put all these features behind me in this slide in context of other things in the platform. Very quickly, and I'm going to go through each one of those in a separate slide. In the space of virtual networking, you can have now user-defined routes. So you can, for every subnet in Azure, decide up to 256 routes where you want your traffic to go. You now have more flexibility over the use of your public IPs, be able to assign them to VMs more dynamically. You can have multiple load balance IPs for same VM or multiple VMs. We also have a brand new DNS service for domain hosting. This is a global edge Anycast-based service that you can use to host your DNS names. We also have a new set of APIs as part of the Azure Resource Manager. Very powerful APIs from low-level RESTful APIs, PowerShell, many other languages like Java, etc., plus a JSON-based template system for defining network topologies and the like. And by the way, guys, just a reminder, we have a talk in each one of those big bullets. In the network virtual appliances space, we have increased the number of supported scenarios and increased the number of partners set. And you'll see some of the partners soon as well. And again, some of our partners are with us on stage in other talks today, this week. For ExpressRoute, which is our connectivity solution between on-premises and the cloud, the private connectivity solution, we have 2 major new feature sets. We have an add-on SKU, an add-on product for ExpressRoute, ExpressRoute Premium, that adds more enterprise features. You see them in a second as well. So if you're a big multinational corporation, for example, with a very big wide area network, you can now connect to Azure in multiple ways and through many, many routes and so forth. We're also going to have ExpressRoute for Office 365. So ExpressRoute now becomes not just a connectivity solution between corporate networks and Azure, but it's also the same solution for connectivity between corporate networks and all of Microsoft services. And lastly, in the VPN space, a feature a lot of people wanted, which is to coexist with ExpressRoute. That is, you can now build global networks with multiple private connectivity and be able to fail over to a VPN solution if need be. We also added a new gateway size that helps you choose between a spectrum of gateway sizes and features as well. OK, I spoke very quickly now for a reason, just to give you an idea what I'm going to be telling you in this talk. OK? From now on, I'm going to hopefully speak a bit slower and tell you first about our global network, which enables all of this, then for each sub-area, a bit more about the features. OK? My marketing slide, which I will not say much about it, except to say that it actually informs what we do. We invest in hyperscale. I'll tell you more about this in a second. We invest in enterprise grade. For example, the ExpressRoute Premium SKU is a very good example of that. And we invest quite a bit in hybrid solutions. Connect what you have today on premises in your data centers to the big cloud out there. It's about both sides, guys. Okay? Let's talk about scale for a second. We have a huge scale in Azure, guys. I mean, it's really difficult to overemphasize this one, if you will. We have a hyperscale footprint around the globe with compute regions throughout the globe. We basically have 19 Azure compute regions out there. We are more than AWS and Google Cloud combined in the number of regions we have in Azure. Just to give you an idea, this is a global network that is experiencing hypergrowth. Some numbers behind me. You can see the slides later. Storage is growing, number of objects in Azure, direct users, SQL, we have numbers like this. The implications, of course, is that with this hypergrowth, you need to have hyperscale. So this is the scale slide about networking. And I want to mention a couple of those numbers. To hit the cloud, to reach the cloud, you have to go through the network, of course. And if you are sitting here in this event trying to reach Azure at the moment, you're going through some connectivity solution, through some ISP to the cloud. Microsoft has more than 85 exchange points between basically the cloud and ISPs out there. We have more than 4,400 connections with close to 1,600 networks out there. What this means to you, when you're traveling, you can really hit Azure from anywhere with very good performance and connectivity. When your customers are using your service that's running in Azure, you also have a great internet connectivity to Azure. It's very important to realize that there's a back-end network that many corporations have for which you can connect through ExpressRoute or VPN solutions. There's also the internet at large. And for that, you need to have very strong internet connectivity. And that's why we have invested from the early days, from Hotmail days, from Passport, MSN Search. Remember those names, guys? We invested from those days in a big global network. You can see the big numbers, how many millions of fiber we have in data centers. I mean, if you've ever seen one of those big data centers, it's a sight to be seen. And I guess marketing likes these big numbers. We can wrap around the earth 4 times or something with the fiber we have only in the US. And it's billions of dollars of investments. Why am I showing this slide? Because a cloud without a very strong wide area network is not really a cloud. Other competitors have big buildings and they have software, which is great stuff, but you must be able to connect them with a great first-class wide area network. And by the way we figure our connectivity is we look at the globe. We look at where the customers are, where internet users are. And based on that, we have all the interconnection points I mentioned earlier, or the thousands of networks we interconnect with. And that's how I can guarantee you that you can reach the cloud from anywhere very quickly. We have our own optical transport network in the US. We have fiber across the globe that builds the underpinning or wide area network. And with this network, of course, we have the regions. And for those of you not familiar with Azure, that's where you decide to run your applications. That's where you can decide where to store your data. And you can do it, of course, in multiple regions at the same time. Look at the sub tag there on the slide, guys. We are one of the largest networks in the world. And to play in the cloud space, this is a price of entry for the cloud. Okay, told you about the wide area network, what we do outside between the globe and the like. If you double-click on any of our regions, our data centers, you'll also see a shift in how the network has been built. The classical network used to be designed for basically north-south traffic. Some request comes from the internet, it goes to some front end, maybe some middle tier, hits some database, and then goes back again. Not east-west traffic. Things have changed. Now the cloud is built for a lot of traffic to go east-west within the cloud, in addition to going in and out. So without going a lot of details, because this would be a whole talk, to be honest, it changed from a simplistic sort of layer 2, 3 type of network to mesh-like layer 3 network. And this is key. If you run in Azure, do any measurements, you'll realize how fast this is because the network itself has multiple paths in a mesh-like architecture. And by the way, if you're interested, catch one of us after the talk. We can give you some papers of how we actually build this thing. Lots of details out there. We've been very open about our technology, by the way. So I talked about the WAN in data center. What fuels all this is basically one of the strongest software-defined network architecture out there. We shifted from buying proprietary hardware that sort of has to be wired in a certain way, managed typically by humans, etc., to a software model where we basically use, by and large, commodity hardware and very fast switching fabrics, basically, interconnects. Our software manages the whole thing very automatically. And a key thing I want to tell you is that the same software stack is making its way to Windows Server. Actually, I have to rush right after this talk to give a joint talk with Windows Server about more details on this space. So we are giving you an SDN stack today in the public cloud. You can use it right now. And you're going to be seeing these things in Windows Server as well. Same bits, by the way. Same SLB, the software load balancer, is going to be available on premises. Same virtualization stack. And again, if you're interested, there's a talk right after this one in S101 about this. Okay, let's talk about the Azure picture, if you will. This will be, for those familiar with you, a simplistic picture. For others, give you the basic foundation. In Azure, you decide in any of the 19 regions I mentioned you can go instantiate a virtual network, one or many thousands, whatever you want to. A virtual network is an encapsulation of a bunch of networking resources. It's a virtual thing. It's an abstraction. You can bring your own IP addresses in it. You can segment it with subnets. You can control how the traffic is entering it, how you do ACLs within it, and so forth. Okay? So you decide, I have a virtual network, you have 2 and 3. What you have been building on premises, you can effectively build it in the cloud. Inside a virtual network, you can run your applications. They can be ISVMs, they can be web role, whatever the case may be. Now, your clients, yourself, your customer, can then go and connect to this virtual network. How do you connect to it? In this case, over the internet. All the peering stuff I told you about earlier, that's how it works. The packets come from wherever the customer says over the internet. It hits one of our peering points, immediately jumps on our WideA network. We go and hit your IP inside your VNet. And there you have lots of flexibility. You can have an IP per VM, one per load balance per server. So you can see more of this in a second. You can ACL, put network ACLs on there, decide who can actually reach your services. You can do load balancing, as I mentioned earlier. There's a bunch of DNS services. I'll tell you more about them. And behind the covers, we have a global distributed denial of service protection system as well to protect your system out there. So again, put VNets in the cloud, hit them through the open internet, or you can connect privately to your VNet. And you can do it in 2 ways, by the way. You can do it through VPN services, where the packets themselves go over the internet, but you go through our VPN connections. I'll show you what we support and so forth. And this is very easy, to be honest. You can do it from your laptop right now. You can do it from a device on premises. Or if you really wanted to, and you have a corporate network, and you want to have a private connectivity, we have ExpressRoute, which gives you back-end connectivity that bypasses the internet. Basically, your corporate network is met at an edge location with our WideA network and bypasses the internet completely. And we can guarantee that. And you decide what topology is. And I'll have more slides about this as well. So what I'm going to do next now is take this big picture, double-click on one of these, each areas, if you will, and tell you more about the features. take note of anything that interests you, and we can tell you offline which of the 6, 7 sessions we have that you can go to if you want to for more details. So let's talk about internet connectivity first. We have 2 DNS services that, like many of the services I'm discussing today, are optional for you. You can mix and match, you can use them if you want to. We're announcing a new service, the Azure DNS service, which is a domain hosting service. You can integrate it with your VMs. You can bring your DNS zones in it, and you can basically serve DNS from it. I'll tell you more about that in a second. In addition, we have Traffic Manager, which is a DNS-based service that allows you to do traffic management. You can do global load balancing through it, and you can, through policies, decide what the best way your customers can reach your service. So for a DNS service, this is new. It's a global DNS hosting service. Simple API, you load your DNS names, we host them for you. The way it's implemented is we have a global footprint of edge locations. They're all over the globe, and we're expanding the number of edge locations. And it's an anycast-based system, which means depending where your customer is, where you are, you will basically end up in one of the close-by edge location that serves your DNS records. And the DNS edge location go to our origins, which are run in the major Azure regions. It's a very robust system. Frankly, you can lose edge location for whatever reason, and anycast will shift you to a next edge location. And ultimately, we revert back to the origins, which are really running in those mega data centers I mentioned earlier. So a very robust, global DNS hosting service. We're announcing it this week, and we'll be increasing the number of edge locations as we go forward as well. Okay? In addition, we also have Traffic Manager, which is an existing service that allows you to do DNS-based traffic management policies. And there are a number of policies. I mean, a simple one to explain is a global load balancing type of policy. Depending where you are, you can end up in one location or the other. You can load the balance between. There's a bunch of policies you see in front of me. Latency-based policy, which gets you to the closest location. Basic round robin for load balancing. And a failover policy as well, where we say is, this is my major service running, say, in US East, but if something goes wrong, fail over to US West. And a few months ago, we announced the ability to nest these policies. So we can end up with very flexible, multi-level set of policies. So talk today about a DNS service and Traffic Manager, I think around 1 p.m. or so, 1:30 p.m. So I told you about how you can use DNS to reach your service. Now, ultimately, the packet will reach some IP address running in your VNet. We actually, if you look carefully what we have done with this set of features, we have cleaned up our semantics for public IPs. Now, you can use the notion of public IP, and I'll tell you more about the APIs, that you can use them either to reach a VM, or you can use them to load balance a bunch of VMs. I'm dropping off for a second. So for instance level IPs, you can assign them exclusively to a single VM, and they're yours. You can do anything with them. You can do an FTP service in there. You can play around with the port, etc. You can use it to manage VMs directly, etc. And you'll see in a second, you will be able to assign DNS names to the individual VMs as well. Or you can do load balance IPs. You declare that I want this IP address to be load balanced among a bunch of VMs, and we take care of it. We take care of all the policies in there. And without going through lots of details, we have lots of policies that you can do. This is layer 4 load balancing, by the way. Okay. This stuff has been there for a while. What we are now having extra this week, you now can have multiple load balance IPs, which means you can have multiple IP addresses that are load balanced among a set of VMs, or frankly, the same VM if you wanted to. And a common use case is you may have multiple SSL endpoints for a service. So your service could be a bunch of VMs that you can scale up, scale down. and you can front it with a bunch of IP addresses. And as I mentioned, you can actually do it within a single VM as well. So if you want to have multiple applications within the same VM, you can do the same thing. You can load balance multiple IP addresses to the same one. The theme, guys, is very simple. We have had foundations in Azure for 2 years now. We had a bunch of features shipped, if you will, a year ago or so. Now we're really, if you will, polishing the application, the APIs and the feature set. So for example, this was an asked-for feature for a number of months now, and now we have it. So you have a lot more flexibility how to build up your service now. Again, this is new. In addition, we have enhanced reserved IPs. We had the feature to be able to reserve an IP. Now we can do it basically for existing IP addresses as well. And the motivation for reserved IP is once you have an IP address, you can reserve it, it's yours. You can tell your customers about it. Some customers, for example, want to echo the IP address on premises, make sure that the IP stays constant and build a network infrastructure around that. You can do this now. And the way it works basically is that you have an IP address in your hand, you can assign it to a service or to a VM, and you can move it around. And you can keep it back in your own pocket as well. And again, guys, all these are optional. You don't have to use any of this stuff, but they're tools you can use to build your service. And this is new as well. Remember how each VM can have its own IP address? Now you can have a fully qualified DNS name for each VM as well. So you decide what you want to call a given set of VMs. We number them automatically for you, and we manage them for you. So for example, suppose you have a bunch of VMs and you are scaling up or scaling down the bunch of VMs. We will take care of the names stay consistent and the number appropriately as well. And this is great for managing your VMs directly. You don't have to go through a load balance IP for this. You don't have to go guess an IP address. You can just go through the name. And the way the name is constructed is based on your cloud app namespace. You say, in this case, it's web role. You call that this way. And we number them automatically for you as well. Okay? And this has been an asked feature because of, as I mentioned, manageability scenarios. So I told you quickly about DNS, traffic management, how to reach your VMs. Now let's talk about the virtual network itself, the envelope in which your VMs, your application actually runs. Quickly, as I mentioned, you can bring your own network inside the virtual network. You can have multiple subnets. You can let us assign the IP addresses or bring your own IP addresses. And by the way, if you happen to have a public IP address you want to assign to your VNet, you can do this as well. Okay? As long as they remain private within the VNet. You can bring your own DNS service or use our DNS service. And you can do things like network security groups, which I mentioned earlier, hackling and so forth. Okay? So the VNet or the virtual net is a foundational concept, if you will, in which your VMs run. Guys, if you're a bit worried about how to configure this thing, I will mention at the end our new template-based system for managing this. We are publishing templates already. I can show you a bunch already online. You can go to GitHub, get them, look at them, and they're predefined all sorts of topologies like this. So unlike the old days where you had to go do things by hand and know exactly the PowerShell command and the like, now we have templates for all of this stuff. And again, there's a whole separate talk about that as well. Okay, so these are the VNets. We've added new features. This is a biggie. User-defined route is a big one. Because if you ever had to do very sophisticated topologies and maybe put some virtual appliances in there, you will need this thing. Now, with user-defined routes, you can control the traffic flow inside your VNet based on your rules. Basically, for each subnet within your VNet, you can attach a routing table. It's as simple as that. We give you 256 routes per subnet. And depending on the address prefix, we go to the next hop. It's a very powerful mechanism because using it, you can build now topologies where you can put things like virtual network appliance, you can put your own firewalls, You can force traffic for certain subnets to go certain places. As simple as that. Some enterprise customers want to force certain traffic, say, from the backend database to be scrubbed back on premises and back to the cloud. You can do that. Or you can force some other subnets to go to a certain place in the cloud to be, again, through a firewall, a router, an IDS system, and so forth. You can do this right now. So again, this is a biggie guess. I mean, there were certain scenarios without this one you could not do. Now you can do virtually anything you want to.
Can I ask you a question about that?
Please.
So before you announced this,
yes,
I could force traffic inbound, and then that traffic had multiple ways in which it could egress outbound without me seeing it. So this solves that problem, you're saying, right?
The question is about the details of user-defined routes. To a large degree, yes, but I prefer if we can better discussion toward the end about this one. Okay?
Because then my next question is, do you have a role to support this so the server administrators cannot get past it?
So with the NRP, with the new API set, now we have role-based access control. So
and it addresses this function.
You can apply it to this function. Again,
So
I have, yeah. The question just for the recording and for the audience is, can you have now multiple roles, as in humans, who can do certain things as opposed to other folks? And the short answer is, with the new model for management, the whole ARM model, you can have role-based access controls now. So you can define who can do what to the system if you want. And let's talk more offline.
Yeah, there's a lot of detail.
A lot of those. And if you see how many slides I still have to go, I want to talk to you offline about it. Okay. So again, more details here, but you define, the ability to define the routes is very important. And I want to touch on one thing, which perhaps the speaker is also alluding to. Once you decide on a certain topology, the application itself, the VM itself, cannot change it. You know what I'm saying? You can, as an administrator, say, the following subnet have the following rules, and they have to go this way. Nobody can change this thing but you. So if the VM is compromised or running some application, the VM actually doesn't know. All the VM knows, I'm putting an IP packet on a network, and somebody have defined the network where this prefix has to go this way versus that way. Again, it's very powerful. You will need it if you have compliance regimes, rules, corporate network for scrubbing the traffic and so forth. And combined with the virtual appliances I'll discuss in a second, you basically have the building blocks. This is an update. We made multiple NICs more powerful. We can now have up to 16 virtual NICs per VM, network adapters basically. And you can apply network security groups and the routes to all NICs in your system as well. So if you've been following us, we had less number of NICs before. It could not apply all these features. Now we can mix and match. And again, this can combine with the previous features. It can help you to segment the network any way you want to, basically. And I'm hoping with 16 NICs per VM, nobody complains to me about this number anymore. We used to have 2, 3, 4, 16 is a lot, guys. Do you mind if we can have the question toward the end? But please hold the question. I can't even see you. I'm sorry. So I touched on securing the network, and this is just a very quick overview of what we have, because it's a combination of the features I mentioned. But the way we view network security is a layered approach. We actually have a DDoS prevention service, guys, that's not exposed to anybody, but that's how we make sure we scrub the traffic and use the power of our wide area network to handle DDoS. And the internet is a very wild place, as you know. There's somebody trying to attack somebody every second or every day. So this thing is part of the value add you get with a big cloud provider like us. Beyond that are a bunch of mechanisms that are yours. I touch on some of them. I'm going to touch on a bit more of them as well. But you can put ACLs for the traffic coming into you. The VNet itself is an isolation domain. You have network security groups, which are really the same as ACLs, to be honest. You can apply them within the VNet. And of course, within your VMs, you can do whatever you want to, including having things like firewalls. The NSG, Sphere, VNets, and ACLs are under your control. And it's a service from the platform. The firewall is whatever you want to put in your VM, and the DDoS protection is something we do transparently for you. So that's how you want to think of network protection, if you will, and isolation for the traffic that's coming from wherever it's coming to your VM. And by the way, the picture is simplified, because if you wanted to, you can even avoid the internet bubble there and have a direct connection as well. So one of the mechanisms in the previous slide are network security groups. The same thing we've had for a while. So we're not adding new features here. This has been there for a while. But in a nutshell, when you segment the network and so forth, you can also have ACLs, access control lists, on the network. You can apply them to each subnet or to the VMs within the subnet. And they basically allow or deny rules. And the beauty of this, by the way, is that if you apply them to a subnet, they automatically apply to all the VMs within the subnet. If you scale up, scale down, we'll automatically do it. And we're very proud also how fast this thing is. You can apply ACLs very quickly through a bunch of VMs. If you're not familiar with this one, again, the combination of network security groups and user-defined routing plus multiple NICs, I think you have a lot of flexibility now in the topologies. And along with the templates we are publishing, you can see the patterns of how to build these topologies. Okay, and again, guys, there's a talk actually in every section here somewhere in the event. So everything I told you in the last couple of sections was about how the VNets can be structured and how you can do subnets and ACLs and so forth. A key component is, after you figure out topology, is you may want to be able to run an off-the-shelf network virtual appliance. You may want to run your corporate mandated firewall stack or IDS system or router or even one optimizer, et cetera. And this is what this is about. So we have partnered with the industry to be able to, for you to be able to use off-the-shelf virtual appliances, and we have put them in an Azure marketplace. So the VMs are ready to go for you. They're configured and ready for you to go. Quickly, these are virtual machines that perform specific network functions. Traditionally, we used to always have to buy them in a piece of hardware, put them in the network. They may end up being a layer 2 device, et cetera. Nowadays, most vendors will either sell you an on-premises hardware device or a virtual appliance, be it on-premises or in the cloud. And the focus typically is on security, application delivery, layer 7 load balancing, and so forth, and WAN optimization. These are typically the categories, although you can squint and see different combinations. And frankly, technically, they're typically based on Linux stack or a FreeBSD stack, sometimes Windows. We support all of the above, of course. If you have, if you're in IT, if you have network IT policies and so forth, you probably already know which ones you use, which ones you should be using. And our job is to give you both the plumbing, like I described earlier, subnets, what have you, and the specific brand virtual appliances for you. And as I mentioned, the easiest way for you to use this thing is to get them from the Azure marketplace. We have worked with the partners, configured the VMs, we have tested them and so forth, although you can also bring your own as well. So some scenarios, and with some brand names that are actually supported on Azure. One scenario is that you can build a DMZ in the cloud. The DMZ in this picture has a firewall, has a router, and has an IDS and IPS. Again, you decide how you want to do it. The firewall could be configured to make sure that all your internet traffic has to go through it, through your corporate policies. The router can be configured to change the traffic with the user-defined routes I mentioned earlier to whatever you want to within your virtual network. And for your IDS and IPS can be used to scrub the traffic, perhaps as a way, if you connect your on-premises to the cloud, to scrub all the traffic. These are examples, by the way. The brand names are supported. The topologies are your call. And again, we are publishing more and more templates to tell you how to do this thing as well. So this is an area where you can apply them to security domain. You can also apply them for layer 7 load balancing, application delivery controller type of scenarios. And you see the brand name A10, Citrix, F5, and KIMP, where you can put them inside your virtual network, and depending on how traffic comes to it, apply whatever policies these vendors support. And again, we work with all of them as well. You probably have one or more of them on premises already. Now, the same technologies apply to the virtual space in the cloud. Third scenario has to do with WAN optimization. And you're familiar with Riverbed? And so this is the example, where you may put a Riverbed device, a steelhead on premises and one in the cloud, and then you can compress, optimize the traffic between your on-premises and the cloud. And guys, you can mix and match these scenarios, by the way. But every brand name I mentioned is supported in Azure. They're a partner of ours. We actually have a bunch of partners. These are current partners. We have, this week, added more partners, and importantly, we have increased the number of scenarios that are supported. If you've been following us, there were scenarios not totally supported because we did not have enough NICs, for example. There were some scenarios not supported because user-defined routing wasn't there. So the plumbing we added now enables more and more of the scenarios. If you're networking, if you have IT policies require these appliances, now we can use them in Azure. We will be adding more. We'll be adding more appliances as well and more scenarios. And if we're missing one or the other, please tell us. We are listening. Okay. And by the way, there's also a talk on that with demos with some of these vendors as well. So you can find the talk is available here as well. Let's talk now about connectivity between your private network and the cloud. And what are the best ways for you to connect to us? So there's always internet connectivity, which is where the vast majority of your customers, your clients, your employees on the road, if you will, that's how they're going to hit the services out there in the cloud. And that's why strong peering with ISPs is very important. That's why I mentioned that earlier. But can also have private connectivity to the cloud. You can do it in, broadly speaking, two ways. Through VPN over the internet, or through private connectivity bypassing the internet through ExpressRoute. Okay? So the VPN services can be either from a laptop through a point-to-site type of VPN service, or from on-premises through one of multiple VPN vendors, which I'll show you a list in a second, that are configured in your corporate network to hit the public cloud. You can also have ExpressRoute where you can bypass the internet completely and go through your network, through your network provider to us directly bypassing the internet. I'll say more about all of these. So for on-premises VPN ecosystem, we are increasing the ecosystem. These are the vendors we support today. These are the on-premises VPN devices that you may have already in your corporate network. Some of them are hardware devices, some are software devices. And you can use them to connect to our VPN service up in the cloud. Yeah. And for those of you who are familiar with a VPN gateway, it's a service, it's highly available. You say, I have one of these on-premises, connect there, it's connected, etc. Now, you can also use ExpressRoute for private connectivity. So a typical picture for public or internet connectivity is the one on the slide at the moment. You're actually connecting from wherever you may be, from a branch office, corporate headquarters, your data centers, on-premises, through a public internet to the cloud, and you can put VPN over it. Very popular solution, very popular as well. If you so choose, you can actually bypass this totally and go through ExpressRoute. So basically, you can then configure it in such a way as your corporate network can appear, or the cloud can appear as part of your corporate network. And there are multiple flavors of this thing as well. The only issue, by the way, is that talk about this was yesterday. Don't ask me why. So if you missed it, I will point to you online. But we have a lot of details about ExpressRoute here. So what is it really? You get predictable performance because you are bypassing the internet. You are not under the mercy of your local ISP with whatever the packets are happening and so forth. You know what the path is. It's secure. your packets will not go over open internet if you don't want it to. The packets will stay from your on-premises through whatever your provider is, and I show you a list of providers we support, to our wide area network, and they stay there. And you can get high throughput. A given circuit can be up to 10 gig, and you can have multiple circuits. And it's highly available, by the way. It can actually be lower cost than the internet if you are pumping a lot of data. And the details are on the website, but if you have the need for a lot of data, especially for predictable data needs, it can actually be cheaper than using the regular internet connectivity. It is also the way to connect to Microsoft in general. So far, it's been used to connect only to Azure, to VNS in Azure, and to some services in Azure. Now, it's becoming the service to connect to all of Microsoft services. Chief among them, Office 365, Sky for Business, and you're going to see other services as well. And the beauty of this is the same circuit, which is highly available, which can be configured by somebody other than your rest of your employees, if you will, can be used to carry the traffic for all these Microsoft services. You don't have to buy multiple circuits. The same circuit will work. You may want to buy multiple circuits for extra throughput or for redundancy for different paths, but all of them will carry the traffic for either going to your virtual networks, Azure services like storage, or for Office 365 and Link for Business. And this has been a very high requested feature as well. And I'll show you a roadmap in a second as well. So these are the current supported Express Route partners. We actually have most of the top 15 telcos in the world here. We have some of the big ones. I will not read you the list, but you can see some of the names there. Plus a longer tail of regional providers. And depending which part of the world you come from, you're going to have one or more of those providers on the slide that are dominant in your space. And if you're from a big corporation, you probably already have a wide area network with one of the telco providers behind me as well. And without going too much details, you have flexibility here. You can have a sort of an Ethernet exchange provider type of connectivity, or if you have an MPLS, global wide area network, you can use that to connect to the cloud. Again, it's a deeper discussion here, but if you're anywhere near the wide area network, you know what I'm talking about. You can mix and match as well. This is a global picture of all our access points. So in addition to choosing where to locate your data and computation in multiple regions, you can also choose how to enter our wide area network. These are meet me points. And you may choose them to be in a certain area for latency reasons, or you can have multiple locations for availability reasons or whatever the case may be. And you can look at how big the global map is. I can tell you we have customers in every continent here that are using us in some capacity with Express Route. And the combination between us and our providers can get your traffic securely bypassing the internet to any region you want to in Azure. And as you can see, we're expanding this as we speak as well. A very often asked feature was people wanted to be able to mix and match Express Route and site-to-site VPN. And the main scenario here is you can have multiple circuits, each highly available, but if something goes wrong, you want to be able to fail over seamlessly to the internet. You can do this right now. So you can have a virtual network connected from multiple locations through Express Route in the previous slide. And through routing, decide which route is the best to get there. And if all else failed, transparently fail over to a VPN connectivity as well. Trust me, if you're a multinational here, you want this one. People have been asking for this. Now you can have a very flexible topology system here. I'm also pleased to say that we have a new premium version of Express Route that adds even higher end enterprise features. To my knowledge, nobody has this thing anywhere. You now have global connectivity. You can basically use our wide area network to enter it from any location in the globe and hit any virtual network in any region in Microsoft. So for example, you can enter the network in US West and send traffic to Singapore. We do it over our wide area network, bypassing the internet. You don't have to go worry about transit through somebody else. We'll take care of it for you. And that's why I showed you, by the way, this big global fiber optic network I told you about. Now it's available to you. Others have big networks, but they're closed. Ours is available to you. It's open to you. You get the premium SKU, and you can actually use it. In addition, we've increased the number of routes supported through ExpressRoute. Our current max was 4,000, which is, by the way, an order of magnitude than anybody else I know of. Now we can support about 10,000. Most of you will not need 10,000. A number of you who are in the bigger companies, even you want that. And you will not get anywhere else. We'll give it for you. And lastly, people really want to connect more and more virtual networks through ExpressRoute. So now you can have up to 100, which was a big number. It used to be 10 or something. We went to 100. Hopefully nobody will ask me for more than this, but we'll see. So the combination here of you can transit traffic through our wide area network. You can have huge number of routes, 10,000 routes. Please do check what the competition provides, and then you know why we're excited about this number. And you can have up to 100 virtual networks through ExpressRoute. This is really, really enterprise, high-end enterprise offering is. Again, it's a premium offer, so you don't have to use it if you don't want to. You can use the basic offer we have. We're also introducing a new VPN gateway for virtual networks. So today, sorry, the slide's a bit busy here. Today we have a basic VPN gateway and a high-performance one. We introduce a middle ground now. And again, the difference really in the feature set, the performance, and the price. So the basic VPN gateway is actually very well priced, if you will. It's a highly available service for VPN services. It's limited in that the bandwidth is capped, and also it cannot do the failover stuff I mentioned earlier. We also had the high-performance gateway, which is very high performance, full features, a bit more expensive. Now we have a standard gateway. It's in between. Many people, by the way, start with the basic. When their needs expand, they move up the stack. Or you can build topology where you actually mix and match with this as well. So with the new standard virtual VPN gateway, you can have up to a gig of bandwidth. You can actually do the failover between ExpressRoute and your VPN. Okay, sorry, it's a gig for ExpressRoute and 100 meg for VPN gateway. In any case, the reason we're doing this thing is we want to give you more options. Before, we used to have one size that people want to go beyond. It was difficult for them to do so. And not everybody wants the very highest performance gateways. We have something in between as well. And it's relatively easy to move between them as well. Okay, I mentioned Office 365. We have a timeline and initial partners. Our launch partners for 365 will be AT&T, BT, and Equinix. And we basically enable you to have it in any Microsoft region. It's going to be around Q3 of this calendar year. Bunch of workloads will be supported and others as well. Our intention is every Express router in due course will also support 365 as well, and Link for Business. And you're going to see more and more of this thing coming from us as well. So I will not stand here and tell you, oh, I just finished this thing. It's going to be every month, every 2 months, you're going to see more and more of this thing as well. And please, talk to me or anybody in the team about any specific scenarios you want to support in this space. We're actively investing in this. Okay, one more topic, then if there is time, we want to show you a quick demo, right? Okay. So remember I mentioned templates, mentioned APIs and so forth? So I told you a bunch of features. Now we want to make it easy for you to use. So in Azure, we now have something called the Azure Resource Manager, in which you can, through templates, define your compute resources, network resources, storage resources, almost any resource in Azure. And then instantiate it as a service. And basically, we instantiate it for you and manage the application in a sense. So as part of ARM, or the Azure Resource Manager, now we have a network resource provider, which are a bunch of APIs for the networking concepts. This is an eye chart, I know. Sorry about this. But there's a talk on this thing, lots of documentation. The net of this is the following. Every networking concept I mentioned earlier, a virtual network IP, load balancer, and so forth, becomes an object, a resource actually, a RESTful resource. And you can manipulate separately if you wanted to. And you typically put them into a template, describe the dependencies between them, and dependencies between, say, VMs on them, and so forth. And we have an increasing library of these templates. The beauty, by the way, is you pick up the template, you change it, you instantiate it, and you go. If you're a power user, you can use PowerShell. If you want to write code, .NET, C#, Java, you can do so to manipulate the actual resource. So you have a whole spectrum here. I recommend stick with the templates and be able to define them, study them, and then go from there. And the beauty of templates, by the way, is they show you all the details in there. And you typically change a field or the other and just instantiate it. The question, are all these types available in preview? The answer is yes. Yes. And there's a talk on this, by the way, on Thursday, is it, guys? Thursday, okay. And we're going to show you a demo as well. And part of the demo is you can go to GitHub and just click to deploy, and you pick up the template, change it, deploy it, it just works. It's actually beautiful. When the first time I saw this thing, I was impressed. And again, guys, if you don't want to use it, you can go directly to RESTful resources, but stick with the templates. They're very, very powerful. And again, I'm repeating myself here, but this is not just networking. This is for all resources in Azure. So you can describe your application end-to-end using this methodology. Your VMs, application dependencies on other resources, storage, etc. And when you instantiate them, the right things happen in the right order. Okay? Ganesh, you want to do a demo? Yeah. We wanted to put things together for you guys. So we told you about lots of nitty-gritty details, got a couple of good questions. We want to show you how we could potentially put these things together. And again, the templates are a way to describe this thing, but Ganesh here will show you a scenario in which we put some things together. Okay. Ganesh, you want to take it?
Thanks, Yusuf. Can you all hear me? Is this better? Perfect. Thank you. So thanks, Yusuf. So I know Yusuf talked about a lot of different features and capabilities. So what I'm going to try to do in the next 5 to 10 minutes is try to put them all together and show you a quick demo of how all these features fit in together to actually give you a complete solution or something that you can look at and get an idea of what you could build using the feature set that we have in the platform today. So this slide is a busy slide. It has too many boxes and circles in them, but let me walk you through the boxes in them before we jump into the demo and actually take a look at it. So what you have in, actually when I look at the screen, it's to my right, so it's to your right as well. So is the virtual network, which is the extension of your premises or your network in the cloud, or it's your virtual private network in the cloud. You bring your IP addresses to the virtual network, you create it based on what you want. And within that, you can create very many subnets. So you can have a front-end subnet where you have all your web roles and worker roles and so on. You could have a middle-tier subnet, a back-end infrastructure subnet, which is where you run your domain controllers and SQL servers and so on. In addition, you can now, with the capabilities that Yusuf just talked about in terms of user-defined routes and network security groups and so on, you now have the ability to define special subnets where you can actually place your security appliances. So for the sake of this demo, or for the sake of this diagram at least, we've shown two subnets where we are placing virtual appliances. The first one is facing the internet. If you typically want to build a DMZ, you can typically build a subnet where you can place policies and you can place virtual machines for a firewall, typically an A10 or a Fortinet device. As an example, in this particular case, you can pick and choose what you typically want from the gallery of images that we will support in the platform. So you pick and place them in the path. So all traffic coming from the internet. Yusuf talked about cloud services or virtual machines having multiple public IP addresses. So you can actually have these firewalls configured in a way where they have multiple public IP addresses that get traffic into your service. So you can then inspect them or do what you typically want to do with your virtual appliances that you run in that tier, and then redirect them to the appropriate front-end machines that are sitting in your front-end tier. So it would give you a very efficient way of setting your front-end traffic. Now, when you configure routes, and you can do a couple of things. First thing is you can configure routes and say that all traffic have to go from the front end back to the internet through the appliance, the security appliance layer, so that it gets inspected and so on before it goes out to the internet. So you can use user-defined routes to do that. The second thing you can do to protect your front-end subnet is essentially define network security group ACLs, where you can say that this subnet is only allowed to receive traffic to and from the appliance subnet, the security appliance subnet. That way you're protecting your front-end subnet from direct connectivity from and to the internet. All traffic to and from the internet will have to be forced through the firewall layer. You can do similar stuff on your middle tier as well as the back-end tier. Now, for your virtual network, you have the internet edge. You've built a DMZ to secure it. Now, you want to build a private edge that talks to the corporate network or your on-premises world. You could use any of our connectivity solutions. You could use the site-to-site VPN solution to essentially extend your network into your branch office, or you could use ExpressRoute to essentially extend your network into your corporate network and essentially make Azure and the virtual network in Azure as just another branch office within your network. So this is just a high-level concept. So just to show you how this looks and feels, and to give you a true taste of what a hybrid deployment looks like, I'm now actually going to show you a SharePoint farm. A SharePoint farm is a good setup for a demo because it's a generic SharePoint farm. It is a typical classical multi-tier application. It has a front-end tier. It's got an applications tier. It's got a SQL database in the back end, and it relies on Active Directory for for identity. So I'm going to be showing you a deployment where I have some instances of this SharePoint farm running on premises, which is a cage in the Equinix data center in Silicon Valley. And I'm going to show you the Azure part of it run in a virtual network in the US West data center. We've linked these deployments using ExpressRoute. And just to load balance between my front end sitting in Equinix and on premises, we have F5 big IP load balancer. So I have a big IP load balancer running in Equinix as a virtual machine, and I have another instance of that running in Azure as a virtual machine as well. So you could use either of the load balancers to load balance traffic and connect to any of the front ends. Since we are going to be connecting over the WAN, we picked Equinix, which is close by, but typically if you are going over the WAN, WAN optimization really helps services like SharePoint specifically, where it's optimized. The performance would be a lot better if you have a WAN optimizer. So we have a physical instance of a WAN optimizer, a Riverbed Steelhead running in the cage in Equinix, and we have a virtual instance of the Steelhead running as a virtual machine in Azure. I'll show you that as well. And when you consume the cloud, you want to be sure that if some sort of a disaster happens, you are protected for this DR capability. So what we actually do is basically we have this failover capability, and we've set up Azure Site Recovery to essentially protect the entire SharePoint farm. So in case the entire SharePoint farm dies on-prem, we can use Azure Site Recovery to create an instance in Azure. So let's just start with what I have running in Azure. So I have a collection of virtual networks that I have running in here. I primarily have my ExpressRoute VNet, which is where I have my SharePoint farm. It's connected to my premises using ExpressRoute. You can see that I've been pushing in a lot of data in and out. I've got about 10 gigs of data coming in. And you can see that I have multiple instances running within the virtual network. You can see that I have SQL always on configured as a backend. My front end, one of the instances of the SQL always on cluster runs in Azure, and the other instance of the cluster runs in the cage in Equinix. I have a SharePoint client, which is what I'm going to use to log into and show you how the SharePoint looks and feels. Then I have two application servers that are running in the virtual network, and two front ends that are running in this virtual network. I also have a second virtual network that's also connected to this virtual network. So I've connected two virtual networks together, and these virtual networks are connected to the premises over ExpressRoute. And in this virtual network, I have an F5 big IP load balancer running as a virtual machine, and I have a Riverbed Steelhead WAN optimizer as well running as a virtual instance. So with all these things, you have connectivity back to the premises. And what do I have in the premises? I actually have two hypervisors. The first hypervisor runs my my Active Directory domain controller for my premises and Azure. I chose to have only one domain controller, and I've got a couple of app servers running in this hypervisor and the other instance of my SQL always on cluster. On the second hypervisor, I have the other instance of the big IP virtual F5 load balancer and two web front ends. So now let's look at what the SharePoint farm actually looks like. So this is my SharePoint farm. I can select anything, and it's a proper functioning SharePoint farm. So it's powered by a SQL always on cluster that's distributed. Now for this, I had to configure an F5 load balancer. I'm going to first log into the load balancer that's running as a virtual machine in Azure. So this is to give you a taste that in spite of this running as a virtual machine in Azure, it's just as snappy and just as performant as what you see running as a physical appliance within your premises. So it's pretty fast and works really well. So you can see that there are 4 front ends that are running in this virtual machine, and I also have the on-prem pool configured in this. Now we can do the same thing and look at the the big IP that's running on premises. So this is the equivalent of the load balancer running on premises. So you can see that, from an experience perspective, from a consistency perspective, the virtual instances are pretty much the same as what you use on premises. So there's no difference in terms of look or feel or how you manage it. And if you are familiar with using these virtual appliances, we want you to have the same feeling and the same experience when you run them in the cloud. So this is one such example of that. Yep.
You don't sync your two big IPs?
Not yet. So we didn't do that as part of the demo. It's a good thing that we can do that. Yes, you can technically do that. So what we provide is a flat layer 3 network. So you can pretty much place anything on top of it and sync them and configure them the way you want. So the next thing that I wanted to show you is the fact that, we have Azure Site Recovery configured for these virtual machines that are running in Equinix, which means you have to take periodic snapshots of these virtual machines and have these snapshots replicated to Azure. So we are actually using the WAN optimizer to help move a lot of data back and forth. And one great thing with the WAN optimizer is that it gives you excellent telemetry. So all you need to do is just look at your WAN throughput. So we've not been generating data, but if you can see, we've made certain trials and things like that. And if I wanted to actually start pumping data, all I'm going to do is I'm going to actually add a virtual machine that I did not have as part of my protection pool. I'm going to add that virtual machine to my protection pool right now. This means once I enable that virtual machine, which is my first application server, I'm going to say that it's a Windows server. Here is my operating system disk. It's going to start copying over that VHD into the Azure Site Recovery service, and it's going to start taking periodic snapshots of that virtual machine from that point in time and start pushing it into Azure. So you're going to be pushing gigabytes of data or terabytes of data every few minutes or every few hours, depending on what your DR policy or strategy is going to be. So you don't have to invest in millions of dollars in building a DR site. All you need to do is use this Azure Site Recovery service and configure DR. So in a minute or two, if we go back to the Steelhead website and I just look at the statistics, once that connection is established, you'll start seeing the WAN connection set up, and you're going to start seeing traffic just start growing. You'll see from about 1.6 megabits per second, it will go to 300, 400 megabits per second. Right now, the throughput is limited not by networking, but by the disk speeds that we have running on our hypervisors. So networking should typically not be a bottleneck going forward in the way you consume the cloud. Another key thing that when you look at setups like this, and with ExpressRoute, we have different models. So we have the network service provider model, which truly integrates the WAN into Azure. The other model is to use the exchange provider model, which is what this demo is based on. you could get throughputs up to 10 gigabits per second active, which means you could burst up to 20 gigabits per second at any point in time. And your latencies are as low as 1 to 2 milliseconds between the virtual machines that are running on-prem and virtual machines that are running in Azure. So if I was to just show you that, just go here. I'm just going to ping a random IP address, and if you can see, it's about 1 to 2 milliseconds between the premises and the cloud, which is, you're now getting LAN characteristics in terms of your connectivity when you're connecting through the WAN to your cloud. So it's really going to enable you to consume the cloud in a very big way, and you don't have to worry about connectivity or security or any other concerns that you've had in the past about consuming the cloud. And I hope this short demo gives you a taste of how we are working towards making the Azure network look and feel just like what you have on premises. So we are still not there yet. We are almost there. We are getting to a point where there should literally be no difference between a LAN that you manage in your premises and the virtual network that you run in the platform. So with that, we'll do a quick summary and wrap up.
Thanks, Ganesh. Thanks, Ganesh. You can stay here. So guys, very, very quick summary here. We're now going to take a Q&As, but here's a quick summary. I hope we convince you that we are enterprise ready. And just the examples of Express Route Premium SKU, for example, number of routes we can support and so forth, and our global scale. The global scale now, with all the technology we gave you, is available to you, not just in compute, but also for the network as well. We have a strong partner ecosystem for VPN devices, for virtual appliances, for Express Route, and telco, exchange providers, and so forth. And it's an increasing ecosystem. If you don't find your partner here, or your provider here, please talk to us. I'm doubtful that we have missed any of the big ones, and we are increasing the scope as well. And frankly, we have now a slew of new features. You saw the laundry list at the beginning. Here's another one, list over here as well. We're completing the scenarios, guys. And finally, we are very, very excited that you can now have an easier way to manage all these things through the Azure resource management templates. So you can actually compose them and have easy starting points for all these scenarios as well. Okay, guys, we're done. We're going to leave some time for questions, and we can have the question right now, guys. And Ganesh, come and join me, please. So there was a couple of questions. I said, let's wait at the end. Let's have them at the moment. If you use the microphone, it would be great. Go ahead, please. Support for
assistant NICs when they regroup, they get new NICs. No, persistent NICs.
Okay.
Yeah.
I can't hear it.
You're talking about the persistent NICs. Yeah, we do have
So you're mentioning about the case where every time the VM reboots, the NIC instance ID changes. Okay, so that's a problem we are trying to still solve. It's not a problem that we've solved yet. It's something that we look to solve pretty soon.
So the mention of 16 NICs being available, is that available in preview now? Or I don't see any documentation yet on that one online.
So documentation should be updated this week.
But it's available right now via PowerShell.
It should be available, yes. So,
by the way,
so we actually did a major push on all our documentation yesterday. So we also wanted to apologize a little in advance because we are in the process of transitioning our documentation from MSDN to Azure.com. So there's going to be a short period of time where documentation is distributed between MSDN and Azure.com. We hope to resolve it in the next few weeks. So hopefully, going forward, you get very good quality documentation in Azure.com. The question is, are you looking at CenturyLink as a partner? So what we have is the published list that we've worked with. Our ecosystem continues to grow by the day, and ask me this question a few months from now.
What's the plan with IPv6 for public IP addresses?
The question is about IPv6. We are working on IPv6, and we know that there are certain customers and markets that require it, and please stay tuned as well. I can tell you that the global network I told you already, the Microsoft one already supports IPv6, so we have done the investments in the physical layer. We have some investment in the software layer, and it should be available as well.
Great, thanks.
So you guys mentioned assigning up to 16 virtual NICs onto a virtual machine. Is it possible to assign those NICs to multiple VNets?
No, they're all part of the same virtual network.
I had a question on the dates for all the functionality shown here. Do you guys have a roadmap of when you think each of these would be, going to preview and then?
Pretty much the features you saw out here are in production today.
Oh, really? Okay,
Yeah.
thank you.
So there are some services features that are only in select regions. So in the next few weeks, they will be available globally. If you look at our documentation page, you will see where some of our services are available. And
Understood. Thank you.
Yep.
Where can I find your numbers about latency, etc., over connections to China?
So we unfortunately do not publish latency numbers because we don't know where you're connecting from and who your service provider is and how their peering is with us. So
okay, there's a whole chain, but if I use your private network, you have your own fibers. That should be better than the internet, the public internet, I hope.
So you're asking about internet connectivity or connectivity through express route?
Express route to China, for example.
We don't support express route into China. The way the Chinese, the cloud that we run in China operates is it's a completely walled off environment. We are working on enabling express route for that environment. It's not yet there. When we do, you've got to work with one of the service providers to connect, and depending on where your source is. And the way we set up express route is that our edge sites are typically, just like how I showed you, is about a millisecond or two away from the Microsoft data center. That's where we hand off traffic to the service provider, and it's up to the service provider to give you the optimal path from wherever you are up to that peering location. So if you add the latency through their network, plus the 1 to 2 milliseconds through the Microsoft network, that gives you the end-to-end latency story. It's a very subjective number. I can't give you a 10 millisecond or a 20 millisecond number.
And it also depends on the China big firewall, I think.
Yes, so it depends on the service provider in China who would be partnering with us and their network.
If you have more questions on this topic, we'd be happy to discuss right now as well, after we're done.
Is it possible to get a copy of the slides?
Yes,
Oh, yes.
all these slides should be in the Ignite's, you should be able to download all these slides and review them.
Everything is public, guys.
The story with Cisco support for, the Cisco Azure support for dynamic routes. Any news regarding that? I know you have a dialogue with the Cisco.
So Cisco's, there are different series in Cisco's, and the ISR and the ASR series support dynamic routing. The ASA series, which is meant to be a firewall, does not typically support policy-based routing. Only supports policy-based routing and does not support route-based VPN connectivity. And it's got to be Cisco's call to basically give you an answer on when, and how they're going to be supporting that. So if and when they support route-based connectivity VPNs, we will add them to our validated list when we validate them.
Thank you.
All right, so what I was getting to earlier there was kind of to the role-based access controls and how you guys have laid those out. So I've been struggling with the checkpoint solution for the last 4 months, and one of the big challenges is you guys have at last announced the point where you can do the custom routing. So that's going to solve the problem of being able to go completely around the firewall. Like I said, I was always able to get traffic in, but it was always the fact that traffic would go out any way it wanted to go. So you're saying that solves that now. And I guess, will you have a session, or who should I work with from like Checkpoint or such, that can show me how you set up these new policies, how you enforce those and lock those down with RBAC, so that My networking team does networking security does securities, SAs do SAs. And I also noticed not a single time has anybody used the new Portal 3. Everyone's using the 2.0 portal, the original portal. They're not using the new preview portal. Why is that if everything new is supposed to be announced and released in the new preview portal?
So there are 3 parts to your question.
Yeah.
Let's start with.
I can keep going.
Let's start with RBAC, then we'll talk about Checkpoint, and finally we'll talk about the portal. So with RBAC, basically RBAC is a management plane concept. So you will basically, your identity will be integrated with Azure Active Directory. You'd be able to create security groups and define different roles for each of these groups on what APIs they're allowed to set and get and do all these operations on. So once you add a member from your team to an appropriate security group, they will have the appropriate privileges to perform these operations.
And literally those groups have been changing on a daily basis at Microsoft. And even working with the MTCs and Redmond, I can't seem to find anybody that knows what those changes are every day.
We can sync with you offline. Reach out to me and I can work with you in linking you up with the right people.
Excellent.
And we can help work out an end-to-end solution. For your second question on Checkpoint, there's a session tomorrow at 9 o'clock where we're going to talk about virtual appliances. You will get a good idea of what it takes to deploy a virtual appliance into a virtual network and configure it. We're going to have a whole suite of partners coming up and doing their demos. So you're going to be hearing firsthand from these partners on how to set things up. So it would be good. It would be a good starting point to have that conversation once that is done.
Are either of you going to be in that?
We will be in that session. Our colleagues here will be presenting in that session.
Excellent. So will you have representatives from Cisco and from Checkpoint?
Definitely. I believe so.
Okay.
I believe so, yep.
Great.
And for your third question on why we haven't used the preview portal, we're working on it. Part of it is my bad. I'm a lot more comfortable with the old portal, and that's why I did not use the new portal. My apologies for that. But we are at a stage where we are adding all these new networking capabilities into the new portal. Some of it already exists in the new portal, and some of it is still coming. You will see us in the next few months catch up and make sure that pretty much all the features that we have support for will be available in the new portal.
Okay. It's great when you're in the new portal and you click an option and it immediately logs you back into the old one to do that option.
The good news, as you know, is some features ship weekly, some ship every 2 weeks for us. Great. So you're not going to wait for another big event. Next time, if we ever see each other, the stuff will be done.
Okay. All right. 9 a.m. tomorrow. Thank you.
Thank you.
Thank you.
With the site-to-site VPN, is it now possible to preserve the public IP?
Not yet. So our reserved IP capability is limited to virtual machines and PaaS services that you deploy. That's something that we hope to work pretty soon and address.
Right. So this is a real pain point for me. So our DMZ is outsourced to a third party, but I want to be able to build up and tear down my test environment in Azure. And to do that, I really want to be able to preserve the public IP and the pre-shared key.
Absolutely. So you can set the pre-shared key periodically. The IP address, of course, goes away today when you delete your gateway. It's something that we'll look to address in the next few months.
Yeah. It's a pain point, so please pay attention.
Feedback heard loud and clear. Thank you. So unfortunately, Yusuf had to go to present in another session. I'll be here to take on a few more questions.
Yeah, so for a lot of the networking functionality, right, like adding NICs and all that, it was only through PowerShell. Or is there going to be REST or other API support fully now? So
pretty much all the services all the features that Yusuf talked about earlier today are exposed through REST APIs. So our PowerShell, our cross-platform support, our portal are all built on top of our REST APIs. So you will see, and you should see PowerShell and cross-platform tool support released. The other stuff will come on top of it pretty soon.
But that's on the ARM API, right? Not
yes.
The service management.
So everything will be supported through, initially it's supported through, some of the features are only through the service management path. We are making sure that by the time ARM is still in a preview service, in the next few months we look to GA the ARM side of things. When we do, they will be at feature parity.
All right. I'll ask offline on the ARM,
sure.
like the timeline on ARM.
Sure. So thank you. I hope you enjoyed the session. And there are a lot of networking sessions. There's going to be one on DNS later today. There's going to be another features talk that talks about our data center architecture and all that later this evening, and a lot more sessions to follow tomorrow in terms of virtual networking, security, and appliances. Thank you.